everyone, welcome to the stream. Um, so before we get started, a couple quick things. So I've been working with a really awesome artist called, or who goes by the moniker June Artcraft 19. She's helping me put together some images to style up my my channel and website and all that fun stuff. So you might notice have a new profile pic up. So that's just the first of stuff coming along. And then, secondly, I've been thinking hard about how to. So, for our stream, we want to keep, doing fancier and more fun stuff because, that stuff's fun and cool. But I also want to make this a, welcoming place that people come and learn, and absolute beginners who've never seen a line of code. So, what I thought up was similar to what my one of my martial arts instructors used to do. So he'd have kind of two levels of classes running at the same time, and every so often a new beginner class would start up, and then you'd come into the beginner class, and then after a bit you could be in any class. So I think I'm going to borrow his idea. So what we're going to do is we're going to Sunday, Wednesday are still going to be the regular streams for our main project. But then on Thursday, so we'll start tomorrow, every month we'll do like 4 weeks of like starting at complete beginner. So tomorrow will be the first stream of that. So we'll be like very, very beginning of programming, what's variables, all that. And we'll do that over 4 weeks. And then after 4 weeks, we'll start that over again. So basically every month you can kind of jump in real quick and get ramped up. And if you don't want to wait, you can, watch the videos from last time to get caught up too. But the idea behind that is with those 4 weeks is a crash course enough that, you're not going to be a programmer after doing something 4 days, for a month. You can't really learn any skills that quickly. But it should be enough that you'll be able to then follow along with the mainstream and the side projects and, kind of understand what's going on. So tomorrow will be the first one of those. So we'll start those at 8 p.m. as well. So those will be every Thursday at 8 p.m. And then our regular main project stream will still be Sunday, Wednesday, and then we'll have still have random side project ones whenever I have time. So hopefully you'll tune into that if you're interested in programming and haven't really done anything yet. So cool. Okay, and then also last stream, he spent some time putting together these super awesome high quality graphics here. But apparently some of you aren't super satisfied with my art skills. I don't blame you. So, this is a stream for coding, so I want to focus more on the coding. So instead of trying to, create my own and spend lots of time, these were purposely rough just because I wanted to get them all done real quick. But instead of doing that, what we'll start doing is, there's tons of resources out there for free or cheap, game assets. So I spent some time browsing around them, and I grabbed some from itch.io and from CraftPix. So we'll make use of those in our game, and then going forward, we'll keep using assets from them, and also who's the other one? Open Game Art? Is that them? Open Game Art org? Yeah, Open Game Art, and then a handful of others out there. So I'll try to pick out some assets for each project that we can use with. So surprisingly difficult to find good 4-directional sprites out there, though. So, but I found a couple. Nice ones out there. So we have for some enemies, we have this bat. And we have a chicken. So those are going to be our starting enemies for this game. And for our character, we have, let's open this one up. We have the swordsman here, really tiny, and we may have to stretch some of these to get them to work together. So, but yeah, we got him, and then for our scene, we're going to make use of this awesome art set here. So it's like medieval. Actually, it'd be easier if I show you on the website. This one came from Crafty Picks, I think, or Craft Picks. Medieval autumn tile set. Yeah, that's the one. I think. Yeah. So I grabbed the hold of this one for us to make use of. So we'll use these guys, and that way we can have some better graphics and we can play with our stuff. And then also, once June helps me get my channel squared away with graphics and stuff, she's also going to work on a set of reusable game assets that we can, some custom reusable game assets that we can make use of in future projects as well. So we'll do, each different projects will do different mixes of, assets that, June will create for us, and then, various ones from sites like this. So yeah. So, let's go ahead. Let's build up a map. Our map first. Not this map. That map's terrible. And we won't spend too huge amount of time on this, but we'll throw something together. All right. So let's do. So our game screen. Let's pop open our game. So our game screen is 800 by 600. I want about 4x in each direction, 4 times. So if we're 800, we'll be 32 by 2400 will be our map size. 3200 by 24. And actually, you know what? I changed my mind. We will actually put it in here as well. That way we can just export it all. Let's hide this under an appropriate named folder. We'll keep the start button and stuff. Okay, and goodbye. Okay, cool. So now let's make a new map. And so when you're working with tiles, how you make use of them, you can either build it in text, or you can build it in code, or you can go ahead and build up the map and export as one image. There's kind of pros and cons to both, and it kind of matters how big or small it is. If you want to do really big, building one giant image is going to be kind of detrimental. So you'll usually tile it. For our purposes, though, so we don't, it'll be a little quicker if we just build it in Photoshop. We're not making a huge map. So we should be fine with that for now. So I'm gonna make a new rectangle real quick first, and 3200 by 2400. Okay, and this is just our space to snap into. And actually, let me check what's the width of these. They are okay. So yeah, 256 by 256 does. I don't think that goes into this guy evenly, but it might. Nope. Okay, so we want a number that'll go into it evenly. So let's do 15 times 256. So we'll go with 3840. 3840. And 240 divided by 256. Alright, so we'll go with 9 times 256. Or actually, no, sorry, 10 times, which is 2560. 2560. Okay, alright, so there's our kind of boundaries. So, for laying out tiles in Photoshop, what we'll do, we'll go to View. We'll do, so we have, I have Snap-on. That's why I've so many uses. Okay, and we'll do grid. Show grid. Grid, and then we need to edit our grid size. Is that still in here? Maybe. Yeah. Okay, so grid line every, and we'll do the size of our tiles, 256. Let's double check. Are all of them 256? Yep. Okay. Cool. Usually tiles are all the same size, but it's usually good to check. And no subdivisions. Well, one subdivision. Okay, there we go. And now I want to get our land snapped onto the corner of there, which it's not wanting to go because it's lining up with that guy. Hang on. If you turn that one off for now. There we go. Okay, so snap to that. That kicked it off the edge. So let's do canvas size, and we'll make it wider. Okay, cool. So there we go. So now let's just go here, and actually we'll do it this way. We'll put that there. Nope, we'll put that there. And I'm actually going to rearrange these files real quick. Just gonna pluck them all into one place so I can just grab them all. Oh, no, actually that's fine. And we won't do the buildings, but we'll do the other two, or the other however many I have. Okay, so, and then let's shrink this. And actually, oh, nope, not that. There, that's what I wanted. Put these all on one line, that way it'll let me crunch them up tighter. Put it back over there though. There we go. And then we can zoom out, and luckily this isn't super precise, so we'll be able to work at this size just fine. Okay, so first let's just start. Wow, that is bigger than 256 Photoshop. File, let's do place instead. D, projects, assets, this one. Okay, we'll place both of them at the same time. Oops. Nope, that's not letting me place all of them at the same time. Boo. Alright, let's just drop this in here. We'll just shrink it down. Oh, you know what? Is it... What's our DPI? Might be why it's changing up so much. Let's open this in Photoshop. Open with Photoshop. Image, canvas size, 256, 256. Image size, 72. What do we have over here? Image size. Yeah, that's why. That might have affected that guy, but I'm more worried about our... Wait, did he shrink my grid? Come on, Photoshop. Cooperate. No, it didn't. Size. Oh, I guess because I specified in pixels. Yeah, Photoshop's being kind of goofy. Okay. Alright. Let's just do this. Oh, no, that's X and Y. With 256 pixels. There. Let's force it for now. That'll work. Okay, and then pop it in. And then I'm just going to kind of copy paste this guy. And each time I'm going to... Let's zoom in. It doesn't look lined up right. Should be, but... Oh, no it isn't because my rectangle's not auto select, so I'll drag the one I'm on Okay, there we go. Nope. Line up. Why are you being stubborn? You are lined up there. Okay. Just looked weird. Okay. And there we go. Okay. There we go. Alright, so good. So, then as we get them lined up, I'm going to need layers. C, Control V. Copy those. Get those in place. Select all 4. Paste those. Select all 8. And actually, you know what? This will be faster if we make sure this is locked. And then I should maybe. Nah, it's not very difficult. That's weird. Hang on. There we go. No. Why do we have 5 of the 8? That's weird. Alright, never mind. Let's keep doing what we were doing. Lock that guy. Okay. Copy. Paste. Only took 8 again. Or 5 again. Photoshop not going to let me do 8 images at once? It's kind of goofy. There. It's okay with that way for whatever reason. Okay. Keep repeating. Make sure we get them locked in place each time. Okay, so now we don't actually need all of those, so let's just get eight of them. I'm holding down Shift as I click, and hopefully it's selecting them. Okay, there we go. So now we got one line. Okay, paste that. Whoops. Okay. Whoops. Okay. Yeah, sometimes you get these weird artifacts when you're zoomed way out. So you can see here it looks like we have a gap. Zoom in. There's not actually a gap, so. Copy all those. Paste that. Ah. No. Okay. Actually, just drag down. Drag it over. There we go. Yeah. Alright. Let's go back to full. Okay, and we got some extras on here we'll chop off. Okay. And choppy choppy. Okay. Cool. So now what I'm going to do is I want to go down here. I'm going to move this guy up to the top here, because now that I have the tiles, that kind of tells, that's my good indicator for the space. So I'm going to put this guy up here now. I'm just going to have him there invisible, but as a sanity check, so I can pop it on and off and be like, yep, I'm still all under. Nothing's sticking out. But I'll turn it off for now. Okay. Okay. So now we got our basics, we have a fill of land basically. So now let's go in and we'll start getting some road stuff in there. And actually, let's go ahead real quick and we'll just we'll put in we'll plan out kind of we'll plan out some of our buildings and stuff, and then we'll use roads to connect those. So let's not use the castle. Our thing's not quite big enough for that. Here, let's go with one of these guys, and that's going to be extra annoying, the size issue. Let's see. Show shop place. pixel size. Useful feature. Okay. So preferences, general, and skip transform when placing is good for us, and resize image off. Alright, let's try that. Still really big. Is that what size it is? No, it's still really big. Yeah, so this should only be about two pixels wide. A little shorter than that even. So that didn't quite work. Preferences general. And we're not actually going to bake the buildings onto a map, just like we talked about last time. We're going to sorry, I'm thinking while I'm trying to talk. We're going to put the buildings in separate, that way we can get behind the buildings and whatnot. But anything that we don't need to get behind, we'll bake into the map. And that'll just make our coding easier. So I do want that on. That didn't seem to do what I wanted. Because I want it to be smaller. Alright. Places trash. Shown on the screen will not racist, but keep in mind that may mess up your image. Has been the reason we're having these issues, just FYI, is because we have a different DPI for each. And so what's happening is Photoshop's basically scaling it up from its 72 DPI to 300 DPI. And so what it's doing is just like, hey, I need to multiply it to get it up to 300 DPI. So it will maintain like the real world size. But we're dealing with pixel images here, so we want not the real world size. So the real world size is basically the size divided by DPI because it's dots per inch. So like 72 dots per inch, 420 divided by 72 DPI. So its quote unquote real world size is 5.83 inches. So Photoshop's like, hey, you want that real size maintained, right? So that's why it's blowing up that image and it's making it so big because it's multiplying it then by our DPI to maintain the real world size. But we don't want the real world size. We want the pixel size to stay put. And Photoshop's like, I don't do pixels. So one option we have, which we may end up going with, although I was trying to avoid, is we can change our DPI to 72 for this guy. But that'll actually shrink because we're dealing with pixel sizes for everything. And then it doesn't seem to actually do anything. But we want this to be like 300 DPI though, because it'll look nicer. Although browsers don't always render at that size, but that's a different thing. Yeah. Size. Yeah, I don't want you to do that. I don't know. Potato. Skill transform. Beep one done. Always create smart. Maybe you could take that off too. Let's see what that gives us. Still giant. Boo. Alright, well, I think we're we're gonna have to change DPI. I may spend some more time investigating. Actually, you know what? Let's do this. Nope. Image size. Let's show that as pixels. Put its resolution. No, don't shrink me. Stop that. Alright. Alright, so 5,000, 4,000. That's our size. So I'm going to change this, put it back at 5,000, 4,000. Okay, that doesn't seem to have caused the end of the world. Good. There we go. Alright. But yeah, and so, yeah, and the reason Photoshop does that makes sense for the normal case, because normally people are, dealing with real world sizes. But as programmers, our life is pixels. So, like Chrome, for example, or pretty much any of your games, if I give it an image that's 300 pixels, regardless what its DPI is, it's going to show it at 300 pixels. If its DPI is 1, it's still going to throw it at 300 pixels. If its DPI is 8 million, it's still going to show it at 300 pixels. Because Chrome and your game engines don't care about real world size, they care about your pixel size. So they don't even look at your DPI generally. And that's not always super duper true. Like for example, the Apple Retina screen does take into DPI, and there is some stuff like that for, especially if you have a very high DPI monitor. It might cheat and kind of make things bigger, because like it can get way too small if you're on like a high DPI screen and stuff. But that's not something we have to worry about generally. Okay, so let's just place out some buildings and fun things for us to like walk around and whatnot. So we'll place that. And again, we're not going to bake these guys into here at all. We're just laying them out so we can get a look at it. And a lot of times, if you use a like a program meant to help you build these kind of things, like RPG Maker or something like that, they'll have tile building tools kind of built in, so it's just kind of click in place. But we're not using any of those tools. We're doing it ourselves, so we have to kind of go fancy. I want to add a roof. Let's add a roof. Nice. And yeah, and a lot of times you'll get these where you have these broken up. So this is what's called the tile set. And you'll have little bits and bobs that you can play with and tweak and do things. And like they'll so like here you see they gave us the building all together, and then we also have the building blocks for the building. So I can, if I chose to, customize it. Like say I only want to add one, window in the middle of that, and then I can slap on the roof separate and whatnot. Give it a gutter, however I want. So we're just, because again, I want to focus us more right now on the programming rather than the coding. We're just kind of gonna throw something together, because we can always tweak it later. Once you get the core game done, it's very easy to tweak these kind of things, your look and images and layouts and all that stuff. So I'm just kind of throwing a handful of our smaller buildings in place. If we end up with too many, I'll remove some. I kind of like this tile set. It's a nice one. I'll have to remember to edit the README for the project and make sure I give credit to everyone. All of these were paid for, so I don't technically have to give credit, but I like to give credit where credit's due. People spend a lot of time creating these awesome things, so it's worth giving them credit. Okay, so definitely got way too many houses. Let's see, what do we like best? So just double check it. Okay. Let's see. So let's aim for the smaller buildings, because we're not doing a huge area. So smaller buildings will let us move around more. Okay, so that should be pretty good for now. Whoops, grab the map sprite. Let's go and lock those down. Lock. Okay. Alright, and you know what? Let's go ahead and check the decoration stuff. Did they give us any kind of fence? Is that a fence or a bench? I can't tell. I think it's a bench, but we may use it as a fence. Road, decor, buildings, yeah. Okay, this is gonna be our fence. So, I'm just gonna... So just like we were trying to do last time, with having things to block the player off, just to make it make sense why he can't just run for it. Alright, that's way too many. How many do we need? Didn't need to paste those. Okay, one more. We'll let it go off the screen a bit. And so this is one thing I'm doing that isn't quite normal tile set stuff, because normally one of these would sit in one tile like that. But we're tweaking it. Actually, we'll just do this for... Oh, actually, you know what we will do? We'll do this. Position the two endpoints, select them all, and then do distribute. Which one of these is distribute? Distribute. There it is. Or no. Yeah, that one. There we go. Now they're all evenly spaced out between the start and end ones. Okay, cool. So got that. So I have a building. And so these guys I do want to align with the grid, the buildings, because what we'll do, so in the other one, because we didn't have grid aligned things, we were going to go with image collision, pixel perfect collision. But since we have tile sheet now, we might as well, for this project, we'll use tile based collision. Or so basically we'll have some tiles that are not allowed to be entered and some that are. So like this will be one that's not allowed. And then what we'll do for our character is basically we'll arrange everything so that if the bottom of you is lower than something else, it appears in front. So like that instead of like that. So like if this building was down here, it would be in front like that. Okay, let's get rid of these. Well, actually, we'll use these extra fences here. Not you, not you. Not you, not you. There we go. Actually, though, we'll just copy and paste this guy down here. So, okay. And we'll have our zombies come from the left, or our, what do we have, the bat and a chicken. We'll have our enemies come from the left and right for now. So, player has to stay and defend the town because bats and chickens are scary. Okay, let's see here. And again, I'm just kind of arranging these, and then we'll throw in some roads to make it look better. We're still a little crowded. Let's stitch that one and that one, I think. Okay. How do we want to line that one? Line that one like that. Actually, you know what? With this odd-shaped one, it kind of makes me want to use the shape one instead, after all. Okay. Yeah, you know what? Let's do shape collision. And let's ditch that one. Too crowded still. Oh, good. Here. Oh wait, that's a blacksmith thing. That doesn't have a roof. There. Roof fits on that guy. It's a double... or chimney fits on that guy. It's a double chimney. No double chimney. That doesn't look right. Goodbye. Okay. And... line it up. Okay, so there we go. So that's what our layout's going to be. Okay, so now let's throw in some roads real quick. So let's see, I like... Which road do I like better? That one maybe? Yeah. Although actually, is this supposed to be one tile or four tiles together? Not sure. We'll use it as one tile. Well, except we want doors lined up there. Okay. So I'm just gonna kind of create some roads and stuff. Again, I don't want to spend too much on this stuff, too much time on this stuff at the beginning of the stage because we are not coding, and I want to focus on coding, but it'll take a little bit of time. Bring this guy forward. Jeez. Find a lot of things. Alright, fine. Where's our range stuff? Let's open up the layers panel. And actually, you know what I'm doing wrong is these guys, and actually these guys as well. These core 3s are the road. These should be part of map group. Right there. Okay. That puts it below. Wait, that didn't put it below it. Am I wrong about what that looks like? No. Did I miss one? Ah, I did miss some. Alright, put this into map. Because the roads, just like the ground and the fences, or actually, these fences we can't bake into it because, it'd be nice for the player to be able to walk behind them. These ones are going to always be behind the player, so we can bake those ones in. So let's actually grab these ones, which did not grab. Oh, because I dragged them into a locked layer, so now it won't let me grab them. Okay, so got those, and then I have to unselect. Nope. I have to unselect these. So, nope. Unselect. Come on, Photoshop, cooperate with me. Which one's unselect? Nope. Alright, well, let's grab them all like this. Not sure which ones they are, though. Doop, 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 doop. Nope. Doop, 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 doop. Go. Alright, so hopefully... not sure if I have them. Do I have them all? No. Which button is it to hold? There we go. Gotta hold shift. I should indicate which one I grabbed. There we go. Okay. So I'm going to take all these guys and stick them in their own layer. And then we'll move this one up. So we'll just export all that fence line as one image. And we'll do this guy as one image. Okay, so yeah, so that's our map, and then that's our fence down there. Okay. And then... Okay, let's finish up our road. If our road go out of town, and we'll make this kind of the the main road through town. Copy and paste all that. Okay, delete that guy. Okay, and then let's drag in another road. Let's go with... let's try this guy. Have it go down to the other ones, just for a little variety. Nope. Oops, those aren't lined up right. That one's off. I want to get it lined up with the grid, which it's not doing. Oh, no, that one's... yeah, there we go. They were all off, that's why. Actually, we have a bunch of gaps in there, don't we? I want to make it so the only thing you'll snap to is, where is it? Where'd that snapping option go? I've suddenly gone blind. There, it's in view. Snap to not layers. Layers has it snapping to other images, so if I get like one unaligned, they all get unaligned. So let's go back through here real quick, and we'll just snap them real quick to the layer instead of to each other. Okay, so there's those. And let's fix these. Okay, there we go. Now life is a little easier. Yeah, if you can't tell, Photoshop wasn't exactly built with a tile layout in mind. It's kind of built for, photoshopping. Alright, so that one's a little weird. I'm just going to kind of do a half sprite. There we go. And going back this way. Okay, that's good. And then this building, let's scooch it here. And we'll go with the third road type. Sure. Okay. And for our game engine, since we are using our custom built one and everything's in code and we don't have like an editor, this Photoshop will also help us, or this kind of mock-up will help us figure out all the pixel positions of all this stuff. Okay, and then we can add further decoration later on. This should be plenty to get us started. And real quick, let's go. So these little weird extra cut pieces are so we can take them and basically put them on top of here to make it, I've got a weird artifact there, make it look a little less, just completely squared. Let's make sure that goes in map. This road needs to be in map 2. And actually, real quick, let's go ahead group all these base lands together. That way I can lock the just land and then still play with the rest of it. Okay. Put that up top there. Okay, so let's see. Alright. So, yeah, we got one of those, and then there should be, there it is, one facing the other direction. Huh, it's a little short. It may be the wrong one. There might be two of them. Ah, there is. That one was for the end. And if you use things like RPG Maker and you import your sprites right, it'll actually auto add these little extra bits in based on what things are next to what. But yeah, I may actually look around and see if there isn't a is it I don't know, what did I select? Isn't something out there that would make laying out these tiles to generate one final image quicker? And we'll go back and fix that weirdness on the road over there in just a second. And on the building. So building up. And actually, all of this land should be in the map. Okay, alright, so we need to delete those. And then instead of those, there should be, yep, there they are. These little bits right here, which, where'd it go? I lost it, there it is. These little bits go in the corner here. We should have another little bit, which I lost again. Where do you keep putting my stuff, Photoshop? Oh, there it is. Oh, wrong corner. So, right? Doesn't seem to line up quite right. Yeah, it's the right corner though. Unless there's another. No, don't see one. Weird. Oh well. That one, and which corner am I missing? This corner. Okay, and then we'll do this guy. And this guy. Okay, and we'll just copy these two and paste. Okay, this guy gets, let's see, it gets these two corners. And then it gets, bottom that goes, whoop, not there. Bottom that goes fully across. Oops. Suddenly I can't drag. There we go. That was odd. Go. Alright, and then back to these guys. It's hard to know which bit I want to select. There we go. When it's sitting on top of other grass. Okay, and that one's a little tricky. They didn't give us a half, did they? No. Okay, we'll just manually chop this one off. Because if you remember, I drug this guy over, so it's only half of one. So we just actually though, well, yeah, actually before we bother with that, we need to use a path end piece for this guy anyways. So that's what these ones that don't quite make it to the edge are for. Like those, although I want the other direction. That one? Yeah, I guess so. Go, and then that one. Don't know if it's in here or not. Where are you? Oh, there it is. It's behind the house. Nope, don't grab the house. Nope, ungrab the house. That's not the one I want either. Oh well, let's drag it in again. Where did you put it this time, Photoshop? I don't see it. It's disappeared. Photoshop, you're not being very cooperative. Alright. Never mind. Let's go back to plan A. Stick this on here. Grab the eraser. Here. And just on that one. There we go. A little too much. I don't want to quite clip it. There we go. And then is it that one? Yep. There we go. Okay, so there's that, and then go back this direction. Okay. There we go. Do we have a... And just FYI, these ones here, so you can have a much more rough-looking road. That like it's been like abandoned or something. So it looks kind of like that. So like more of the road's been worn away. What am I looking for? I don't see it. Okay. Okay, so we got that. We got that. Then let's get this spot right here, and we should be good. Okay, so this guy gets these two. Oops. These two. Oh, where'd you paste them, Photoshop? Paste in place. Alright, there. Is that lined up? Oh. Those are the ones that I lost track of. Huh. Yeah, it's weird that that one doesn't line up right. It's weird. Sure there's not another one? No? Weird. Yeah. Oh well. Okay, so let's do these two. They're actually not for there. That one gets the corner, this piece, and then it gets this piece. I don't know where I put it. Or, sorry, not that piece. This one. Okay, and then this guy gets kind of the opposite of that. It gets this corner. Still in front. That road must... the road's outside of the map. There we go. Okay, and it gets, this corner. Oh, and you need to go way up too. Okay. There we go. So that doesn't look too bad. And we'll come back in. We'll add bushes and whatnot later. For now, we'll call that good. Okay. So, and now thanks to Photoshop's auto export thing, we should have cool bottom fence. Let's make sure. Yeah, so that's just the fence. Good. And then we have an errors. Oh, I need to go. I'm just gonna delete the ugly one. Where is it? Goodbye, ugly. You have been replaced. I can't delete the ugly one because everything's locked inside of it. Still can't delete ugly. So you have to be visible to delete. Goodbye, 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 goodbye. Oh, these two are still locked. Now I can delete ugly. Group and contents. There we go. Alright, now let's save. Still in errors.txt. Still one called map.png. That's odd. Shouldn't be. Oh. What is that land? We don't need that one. That's an extra. Alright. Let's try saving one more time. May have just been taking a while to generate, maybe? Unless, do I have one in here called map.png somehow? No, don't see one. Wait. Yeah, map.png. Wonder, is it taking a while to export? Shouldn't be. Come on, map.png. Rename it cake.png, maybe. Yeah. Alright, cake.png worked. I wonder if maybe I had a space in there or something that was confusing it. Back to map.png. There we go. Alright, cool. So we got our map there. Alrighty. And actually, because we named that the same, map.png should still pull in. We do need player though. Okay, so player. So actually, what I want to do, I don't want to pull all the sprite titles into there. So let's make another folder. I'm just going to call this one assets, because if I try to put something in here, I'm pretty sure Photoshop deletes it each time I save. So we'll make a new folder called assets, and we need to go wire that up to load from the server. So I'm just going to add one that's just assets generically. And that one will be loaded out of just regular assets. So we have neighborhood assets, and then we'll just have an assets folder. Actually, you should be up here. Part of the use express.static assets. Okay. And then okay. So then let's go ahead. So let's take the sword man. So these images are separate. This is what's called the sprite sheet. And basically each one of these should be laid out an equal space around, like on a grid. And then when we want to animate, we basically just change the position of this big image in what we're showing, and then it'll show up. So should be all we'll need for him. So we're going to move this here, and we're going to call it player. Okay, and then let's go back here. Let's go to our game scene real quick, and I'm just going to, well, I can't do that. Yeah, so we're going to need to, let's create a new type of sprite here in the game engine bit. We're going to call it a sheet sprite, as in uses a sprite sheet. Export default class sprite, or sheet sprite. Extend game sprite. So I'm going to extend game sprite, that way we'll still get all the physicsy bits. Whoop, not that. Okay, and then so this guy, it's still going to load an image, so we can leave that logic in place. But what we're going to do instead is override the render self function. And this is the function that, you may guess it, is responsible for rendering itself. So GameSprite extends ImageSprite, and ImageSprite always just shows the whole image right here. So you can see it's taking from 0, 0 to its width and height, and then drawing it to its width and height. So that's good for regular images where we want to show the whole image. For a sprite sheet, that would not look right. So what we're going to do, we're not going to do that, because that would show the whole image still. We're going to do, so we need this guy to have a, let's see, what do we want to call him? We'll do sprite X, sprite Y, and sprite width, and sprite height. So and actually, let's just we'll use sprite rec, which has all 4 of those in it. And actually, yeah, we'll call it that for now. And so what we'll do then is we'll define, so width and height will be the width and height of one of these cells, and then X and Y will be which one. So like if we are like 5, 2, we would show 0, 1, 2, 3, because we always start with 0. So 0, 1, 2, 3, 4, 5, and then 0, 1, 2. So this one would be the one we would be showing. Okay, so we'll do if image there. So, because we want to make sure our image is loaded, and actually, yeah, that'll be fine. So this one uses render image, which basically picks which of the 3 states, but we only have 1 state, so we're just going to check for image directly. And actually, we'll do const image with height with this. Okay, and then we'll do if image ctx.drawImage, and we specify the image. So first is the X and Y of the from the source image. So this is going to be for us spritex.x times spriterec.width. So that'll be so like if our width is 100 and we're at the second, we're at 2, it'd be 200, so we'd be right here. And then we'll do the width, but the Y is the same deal, so spriterec.y times spriterec.height, and you're getting squigglies because I need to come up here and destruct sprite width. And actually, let's go ahead, this guy's gonna be a long line, so we'll go ahead and break it up. Okay, alright, and then so that's, and then the next is the source width and the source height, which is just spriterec.width and spriterec.height, because we're going to take only that little bit. And then the last bit is where we're putting it in our sprite. And so this guy, we're going to do 0, 0. So it'll be in the top left of the game sprite. And then width and height. So it may stretch it based on what our thing is. And then I also want to override. We have a function in here, sized image, which I thought was there it is. So this guy, we call this to stretch to make the sprite's width equal to the actual image, but for our sheet sprite, we wouldn't want to stretch the whole image. That would be way, way, way too big. So we're going to instead stretch it to sprite rect.width and sprite rect.height. And we need we need to pull it in here. Okay. So that really should be all we need to do for the basic sheet sprite. So let's go ahead, we'll come tweak player to be a sheet sprite instead. So its image is going to come from the assets folder. Did I copy him over? I did, and it's called player. Player.png. Then we need to set a sprite rect, new rectangle, and we'll start at 0, 0 for width and or for x and y. So we'll just start in the left corner, and then we need to figure out what the width and height of each cell is. So let's drag him in here and we'll just kind of measure. Well, actually, we should just be able to do math if it's right. So 1, 2, 3, 4, 5, 6, 7, 8, 9 across, and the total size is 603. 603 divided by 9, 67, and then we'll just double check it's the same this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not. So glad we checked. So let me put that in 67. So our width. This is probably square, but we'll do the math to check. So 624 divided by, and it doesn't have to be square. That's just more common. Oh, actually, this one might not be square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not square. 624 divided by 12. Okay. And again, that's totally fine. Okay, let's see what happens with that. Alright, sheets. Oh, we gotta import sheet sprite. And we don't have to import that one anymore. Oh, right. We were already loading those? Or were we loading those already? Oh, did I already pull them in? I did already pull them into map. Okay. Let's just get rid of them. We didn't use them yet, so. Okay, there we go. Alright, so he's a little off. Let's go. Curious. Okay. Good. Oh, you know why? Because, and I was worried about this would happen, so kind of an order of operations deal happening. So when GameSprite loads, or when GameSprite creates, it'll go ahead and create. Well, actually though, as soon as it does this, it should be setting this already. That's curious. Because it should. So it'll load it up, it'll stick it in there, and then it should call size to image, which should end up calling this sized image. And let's just double check. But our sprite rect should be here already because it should, when it calls new this, it'll create a new of whatever it is, and in this case it should be creating a new player. And all of these class properties that have a value out here should all get set before it moves on to the next line. So by the time it gets there, it should be good. So let's check. It is not good though, because that's 100 and 100. Interesting, but it did call the right version of that, so that's good. But it isn't set to... there's the problem. Okay, we actually have to copy this guy. So, well, no, maybe, yes. I'll flip all out of this. Yeah, cause no, it is a It is calling the right this. Interesting. Alright, so let's log Sprite right here. Alright, so there's player. And he has a sprite rec. And the sprite rec's not set right. Interesting. I wonder, do I have... Alright, first let's just double check the spelling. Spelling's right. Okay, I wonder, am I not properly using the values I pass in here? Ah! Pfft. There's our problem. I'm not using the values I passed into the constructor. That was kind of a bug. Okay, alright, so there we go. He's a wee bit tiny. And actually, he's gonna be a wee bit tiny for this thing. What's 100% look like? Yeah. So, unfortunately, our little guy is a little small. A little smaller than I expected. Yeah, it's weird. He's much bigger. No, he's the same size there. Okay. Yeah, he's just small. So, that's okay. We'll stretch him out. It's not super duper technically ideal, but we'll live with it. We may hunt for another later. Oh, hello. Oh, hi, Hypno. Not making it in inspect, but I am making frequent use of it. I love my inspect element, my Google Dev Tools. Okay, so create here, we're going to call super create. So that'll run all the game stuff, and then let's just make them bigger. So we'll do a multiplier. So times 5 maybe? Let's see what that looks like. Oh, and actually, I'll create the sprite, and then it'll be sprite.width, sprite.height, 67 times 5. Turn sprite. So it'll be bigger. He'll be a little stretched out, but it's not too bad. Okay, and he still moves around from the code we did last time. And let's go down to the road, and we'll see how he sizes compared to the road. Okay, so not too terrible. If you think of this as like, you know, a sidewalk, maybe a little bit bigger. Sprite. Oh, and actually, I just remembered, because the one we made last time was too big, we set the scale to half the size. So actually, if we size him properly, or remove the scale, but our new code doesn't take scale into effect yet. Okay, we'll still remove that. And then, and we need to change our origin, because if you remember, we made our code, we want him to stay in the middle, and then the world will move around him. So we have to tweak the origin in this case. So right here, it's setting it based on the image size, but we don't want to do that. We want to do sprite rec image size. Yeah, we'll have to set this in the constructor because we won't know that until after it's constructed. So, down here, this dot origin equal, and we don't need to redeclare that up there because it's inherited. And then we'll do this dot sprite rec and this dot sprite rec. Okay, so that should get him. He's still like not in the middle. That's weird. But let's make him bigger too. So let's go 8 maybe. Get that done first. Hang on a sec. That was weird. Was it just me, or did like the whole thing shift around him? Did. Okay. But it didn't change size. Okay. So 8's probably okay. Alright, cool. So got that. So now we need to figure out why he's not in the middle. So is he not in the middle? So his origin, and it's probably because of this guy. So we'll do, instead of the shape of that, well, you're going to just use his regular width and height, because we're multiplying that up there, so we need to do it down here. And then he's still not moving. So let's double check. Oh, you know why? Because, yeah, we're going to have to actually set this and create, because the constructor gets called first. So inside this call, it calls constructor, and then I'll set the origin, but I'll set the origin based on the default width and height, because we're not overriding the width and height until after it's constructed. So we'll have to do it like that. There we go. Now he's in the middle. So we got him in there. It's a little slow still. Let's make him faster, at least for now. Max velocity, we'll let him get up to 300. Faster. Faster, faster. We'll go to 500. And we'll bump up his acceleration and friction a bit, so we'll get to 500 faster. Needs to go up a little more still, but that's fine for now. Let's get to the sidewalk. Okay, so that's pretty good sizing, I think. He should line up well with the rest of the world. Okay, so now let's animate him. So obviously right now he's just flying around and he's kind of staying in one state. So to animate him, what we'll basically be doing, and I'm just going to throw something in here real quick. So let's see. So in Game Sprite, we have a move function that's called every time. We want him to change his position. So let's extend that in Sheet Sprite to also update his position, his sprite position. So we'll call super.move because we still want it to do all the changing position thing. And then real quick here, so let's add a new variable. It can be a private called last state change maybe, and this will keep track of state change speed. It'll keep track of when the last time we made him change which image he's showing. And then this one will control how often it changes. So we'll say, let's say maybe every half second he changes to the next step. So this is seconds until change. Seconds between change. So half a second in between each change. And then, so here we'll check if actually, so this guy, if I'm not mistaken, we have it also pass in a now value to move, I think. Or do we? No, we don't actually. I think we're going to start, let's see, move, yeah, move doesn't take in now. So let's have it take in now as well. And we need to go to our game scene and make sure we pass now in. So tick gets now already, I believe. Let's double check that real quick. So scene, yeah, tick does take in now. Okay, and we'll pass both of these into there. Okay, so if yeah, if now is greater than this dot last state change plus this dot state change speed times 1000, because we're putting our value in seconds up here, but we need milliseconds down here, so we're just going to multiply by 1000. So if now is greater than or equal to that, we're going to change his state once. So what I'm going to do for now is just to show you guys the state changing itself, I'm just going to do equals this dot sprite rect.x plus 1 mod How many was he across? 9. And so that's just going to loop us around through 0 to 9. Because if we went higher, he would stop showing stuff. And then he's not doing it. Oh, we need to set this dot last date change equals now, so we can keep track of that. And then he's still not going to show it probably, so let's console log these and make sure. And actually, it's possible, likely, I have a typo. Nope, that's an old one. Okay, undefined. Which one's undefined? Oh, right. Wait, no. Which one's undefined? Now is undefined. Okay, so I'm not passing now in properly to move. So let's go back to our game scene. Oh, right. I call player move here, but I have to pass it. That's not the actual move. This is the actual move that we were just updating. Okay, so there we go. So now we'll animate. But notice that, because I just have him kind of looping through the top row, he's kind of bouncing all over the place. Because the sprite map has multiple sets of animations. So it looks like, so I think these first 4, and actually here, let's open, oh, we already have it open, Photoshop. Let's kind of, we'll draw out some groupings on here real quick, just so we can kind of keep track of which ones are related to one another. So we got these 4 look like the idle animation, facing down. These 4, oh, he's actually 8 direction. Cool. I didn't realize that. These 4 are idle animation facing down right. These 3, oh, I see. This plus this one over here are down left, idle, up. That looks like walking, I think. Not sure. Those 6 maybe? Down right. Looks like walking or running. I guess he's probably running. It looks a little fast. Those. Okay, it looks like that's swinging his sword that way. 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 I think that might be hurt, maybe? Like when he takes a hit. Is that him attacking that way, maybe? Can't quite tell what that is. It's getting a little trickier. That one looks like he's down. Don't know. I don't know. Once we actually have these playing, it should be a lot easier to tell what's going on too. Yeah, that one, it looks like he's like falling down, like he was just defeated. I can't tell what's what there. That, I guess goes with that. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I guess these are connected. Huh, not sure. Okay. And we may not use all those. So what we're going to do, so now we have them kind of grouped up. What we'll do is we'll use we'll go in our code, and for our player we'll create different sets for each one of these, and then we'll set our state. So let's go to Sprite Sheet, and we'll add we'll call it Sprite Animations, and it's just going to be an object. And then we'll just say animations. We'll say current animation equals, and this will be some key inside this guy. And then on player, we'll go and we'll define those animations because they're going to be specific to each one. So let's just do a couple to start with. So we'll do, let's do the walking ones first. So I think that's walking down. So we'll say walking down. And then here we'll do an array of which number it is. So we're going to say, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8. And then this is going to be 9, 10, 11, 12, 13, blah, 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 blah. So all the way down here is, you know, what, 9 times 12, 108, or 107, because we start at 0. So for the hero walking down, it is going to be, so 8, oh, wait, which one did we want? We want this one. So 8, 16, or 15 actually should be. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Wait, 8? Oh, wait, no, sorry. 9 across. 17. So 16, 17, 18, 19, 20, 21. Okay, so 16 through 21. Is that what I just said? Sure. 16, 17, 18, 19, 20, 21. Okay. So, and actually, I have a helper function here called range, which literally creates an array of numbers between 2 points, including both of them. So we'll use my helper function so we don't have to type them all out. Okay, so we have that, and then we'll set current animation equal to walking down, so we'll default to that. Walking down. Okay, so we have that, and then we'll go to Sprite Sheet, and actually, you know what? Let's do it this way. Instead of having this string be here, because that's prone to typos, let's actually just have it set the current 1 there, like that. This dot. Okay, and then, so that'll get set there. And then what we'll do, so, yeah, I actually kind of want to change how we did this guy, the sprite rec, because what we really want is current animation and current step, and step will be 0 through however many steps there are. So in like this guy, it'll be, there's what, 5, 6, 7 steps? 1, 2, 3, 4, 5, 6 steps. So it'll be between 0 and 5, because -1, because we start at 0. That ends up being a lot easier to manage. So here, let's just do we'll do sprite. I'm still fine calling that sprite rec actually, and using rectangle. We're just not going to use the x and y from that. So our x and y instead is going to be current animation. So it'll be, we'll have to do a little bit of math here. So like if this is number 17, we're going to take, or was it 17? This is 17. This is 16. So we're going to do, to get the row, we're going to do current number, so 16. Let me open up a scratch pad. Grab the tablet. Alright, I'm going to do, shrink it down a bit, and get rid of that grid. Sorry for the meowing cat. Started trying to ignore him when he starts meowing, and then when he's quiet, give him pets to teach him to stop meowing so much. Seems to be working a bit, but of course he's not gotten attention since I started streaming, so he wants attention. He's kind of an attention hog. Not show grid. There we go. Okay, sorry. So, if we are on, so each one of these is a step. If you keeps meowing. I'll kick him out of the room in just a second. Alright, so if we're on this one, that's x 0, 1, 2, 3. So x equals 3, y 0, 1. But then for how we do our animations, we just count them all across. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8. So we'll say step 8. So what we're going to, how we switch those numbers around is we need to know the width of how many sprites we have. So 0, 1, 2, 3, 4, 5. So width, well, yeah, width is 5 sprites, and then height doesn't actually matter. We don't care about that. And so then what we do our current step for the x, we do current step mod mod width, and this will give us, so mod is the remainder of division. So if we do like if you do like your old school math you learned in algebra, this is 1, and then 5 minus 1 is 3. Mod gives us this. So for x, that's the number we want. So yay. And hang on, let me get off that green. That green is very bright. There we go. And then for y, we divide and we floor the division, which just means we chop off the decimal. So for y, it is floor s divided by width. So again, if we take that, so like if we did the width, it would be, you know, I don't know, like 6, I guess, 1.6. So floor chops off the width, so we just get 1. So y would be 1, which is what we want. So, and then in our case, we're not tracking how many sprites wide it is. We know how wide each sprite is, and we know the image. So to get this width, we're going to do image width divide by sprite width, and that should be an even number, or else you have a problem, equals this w. Whoop, that's not how you do w's. W. So, let's go do that in our code real quick. So, alright, we'll go ahead, we'll do, we'll calculate the sprite x and y up here, sprite y. So sprite x equals current animation, current step, because this will be like 16, 17, 18, 19, 20, 21, mod width, or mod the number of sprites wide it is, which that number is image.width divided by spriterect.width, because this is the whole sprite sheet and this is one sprite, so that'll give us that number. Okay, and I need a destruct current step. Okay, so got that, and then our y is the same thing. Well, actually no, sorry, our y is not the same thing. Our y, so current step divide by image.width, and actually we'll just do sprites wide equals this guy, because we're going to use this number twice. And then we need to do math.floor to chop this off. Okay, there we go. And then we can just drop this guy in here, sprite y. Okay, so that should still draw it good. And then down here, so we're not going to use this guy anymore. We're going to do current step equals this dot current step plus 1 mod mod how many steps are in the animation. This dot current animation dot length, and actually we'll destruct current step and current animation because I don't like, oh, what is that? Current animation. I like to minimize using this when we can. Current, and I still can't spell current. Current animation, there we go. Alright, so, but we still have the list on there because we're assigning it. So this will basically be, so in the example of our player, we have 16, 17, 18, 19, 20, 21. So step 0 is 16 plus the step. Wait, hang on. What did I just do here? I think I confused two things. No, that's right. Yeah, so it'll be between 0 and 0, 1, 2, 3, 4, 5. And then when we get 5, adding 1 would give us 6. 6 mod 6 is 0. So that'll loop us back around. So our number will always be between 0 and 5. So now, if we flip back here, he should. There we go. So now he looks like he's running down because it's all one animation sequence now. It's probably a little slow. So let's come up here. We'll tweak this. Maybe 0.2. There we go. That's not bad. Although, kind of matches. This is kind of one of those tricky parts that you end up fiddling with. You want it so the speed he's actually moving seems to line up with how fast his feet are moving. But for ours, I think that's pretty good. That feels pretty close. Okay, so let's go ahead. We'll get the other walking directions in. Oh wait, is he 8 directions? Oh, he's not actually 8 directions. He has 4 directions. I was wrong. It's just when he's left and right, he stands kind of at an angle. Okay, so we got down. Let's go Photoshop here. So we got the down running. So let's see. So this is running right. So that would be 22, 3, 4, 5, 6, 7, 8. 20, wait. Yeah. No, that was 21. Yeah, 22, 3, 4, 5, 6, 7. So player. I'm going to get rid of this. Walking right. So it should be 22 through 6, so 28. No, 5 of them, 7. Okay, and we'll start him out walking right, so we can check that one. Okay, there we go. That looks like we got one complete animation there. Cool. Then, so left is after that. So, whatever number we left off on, plus walking left, 28, 33. We'll start him out walking left. Okay, that looks pretty good, I think. Yep. Okay. And then walking up is 1, 2, 3. Well, it's just the next one. So walking up, range 34 through 39. And start him out walking up. Okay. And that looks like a complete animation to me. Cool. Okay. So now we got him walking. So now what we want to do is we'll change which animation is active based on what direction he's moving. So we'll go in player. We'll do this in player because this isn't generic to the whole sprite sheet, to all sheet sprites. It's just specific to the player. So we'll come down here. Nope, player. We'll do move again since last. Well, actually we don't. Well, yeah, we do care because we have to pass them along. Okay, so we'll call super move since last and now. Actually, we'll do this before we call super because we want it to animate the right one. So we'll do. Let's see. We'll do it like this. So let's get the direction out, and we'll get his current animation. And then we'll say if direction, so let's open up our sketch pad real quick. So if, so we have a circle. So this is all possible directions he can go. So if he's 45 degrees this way, he'll be facing right. 45 that way. Well, I guess an angle of 90. 45 to 45. If he's this way, he'll be facing up. If he's this way, he'll be facing left. and if he's this way, he'll be down. So we do everything in radians when it comes to checking math. So um, again, if you're unfamiliar with radians, this is 0. This is pi divided by 2. This is pi, and this is 3/2 pi. So this would be half of 0 and pi half, so this is pi fourth. And then plus half pi, we have 3 pi fourths. Plus half pi again, we have 5 fourths. And then 7 fourths. So we'll check, or this is also, you can also do it negative. It's the same thing, so this is negative fourth. And this would be negative 3/4, which may actually make it be easier for us to think about in our code. So basically we'll just check his angle, and if his current animation isn't right for his current angle, we'll change the animation and we'll put his step back to 0. So if direction is greater than or equal to, and actually though, I just realized, so we cap our direction in, you know what, let's make a tweak here real quick. That will make future math easier. So we have our direction here, and our direction, wait, do I not cap it? Oh no, did I forget to do that? I guess I did. We don't currently cap it. I want to cap it. So let's actually swap it out for a getter setter so we can cap it. Equals 0. And then for our getter, we just return the direction. And then for our set, we will do this dot direction equals value mod 2 times math.pi, because that's one full circle. So basically, like, you know, if you sat there and spun something in a circle, that's 2 math pi, which is the same as 0. That's 4 math pi, same as 0, blah, blah, blah. So what we're going to do is basically each time you do a loop, we're going to cut it back down to 0. But then what I also want to do here is, instead of that, I want to subtract 1 math.pi. Let me make sure my math is right on this. So if we have math.pi, no, I can't do it that way. Because basically what I want, instead of between 0... Instead of between 0 and 2 pi, I want between negative pi and positive pi, which ends up being the same, but it's rotated 90 degrees. So, or wait, negative pi is, yeah, no. Math is hard. Yeah, negative pi is the same as pi. So we would be between here. We'd still have a full rotation, but why does that seem wrong to me? Because it probably is wrong. What am I doing? So 0 is here. Pi is here. Negative pi is here. No, that can't be right. My brain hurts. Let's see, hang on. This isn't that complicated. 2. So if I rotate negative pi, rotate pi. Yeah, they are the same thing. Yeah, okay, I'm not crazy. That's 0. That's, yeah. Okay. But I can't subtract math.pi, because if you set 0, that would be wrong. 0 should still be 0. So I want... So 2 math pi should be 0. 0 should be 0. Pi. No, I am crazy. No, yes, I am. I don't know why that's so hard. Never mind. Screw it. I give up. I don't know why my brain's having so much trouble wrapping my head around that. But anyways, we can pass because it. We'll chop it off anyways. We can pass negative pi and it'll work fine too. Okay. So here, nope. Here, nope. Player. Yeah. Okay. Here it is. Alright, so if direction, but we will have to stick with positive numbers still here. Yeah. 0, pi, more, negative pi to pi, rotation. Hang on, sorry, I'm thinking about that again. So we want it to be if I subtract half pi, subtract 2 pi, that's what it is. Because if we have 1 pi and I subtract 2 pi, it puts it at negative pi, which is what I want. That's what it is. Minus 2 times math.pi. And we'll console log this just to double check that I'm not crazy. I broke him. Oh wait, I'm just using the wrong keys. Okay, so negative 2 pi. Okay, yeah, no, I am crazy. That doesn't work. That gave us between negative 2 pi and negative pi. Yeah, no, that's not right. But if I subtract 1 pi, he goes opposite direction. What I expected. Although actually 0, he just doesn't move. That's a little weird. Should move with 0. Yeah. Oh, wait. No, that's not right either. Oh well, whatever. It'll be between 0 and 2 pi. Okay, so if our direction is... So for this guy, let's go look. So we are less than pi half or greater than that one. That's why I wanted to rotate it, but it doesn't really matter. Okay. So direction is greater than or less than or equal to math.pi divided by 4, or direction is greater than or equal to math dot or 7 times, and actually we'll put the numbers together, math.pi times 7 divided by 4. Then he should be facing left. So current animation, and actually we have to do and current animation not equal to animations dot walking right, then this dot current animation equals animations dot walking right, this dot current step equals 0. Okay, and then so let's go. We should be able to check that. He should be able to now turn left if he's not. Whoop. What did I do? Oh, I don't think this is right. Hang on. Console.log direction. Alright, so the direction is left. It's less than or equal to, so that should be right. Oh, wait. Might need that. Order of operations puts that differently. There we go. Cancel. Okay, so there we go. So now he'll face left if he's 0. And then else if direction is greater than math.pi divided by 4. So, and direction is less than or equal to math.pi times, so here to here 3/4, 3 divided by 4. And since these are all ands, we don't need the extra set of parentheses. And he's not animations.walking up. We can do this dot current animation equals animations.walking up. This dot current step equals 0. Okay, so now I try and move him. There we go. So see, when I hit up, his direction changes, so he'll change to up. So now it looks like he's kind of moving. We got half our directions. Yay. Alright, so let's go get the next one. Else if direction is greater than math.pi times 3 divided by 4. And notice I'm doing less than or equal to on one of them, and then only greater than on the other. That way there's no like point where two numbers intersect. That way it's kind of a clean break. And it doesn't matter really which one I do it on. Just I don't like where you have overlapping conditions because that can lead to some funky bugs sometimes. Okay, so for greater than math pi, and then we're less than or equal to 5/4. Current animation not equal animations dot walking left. Dot current animation equal animations dot walking left. This dot current step equals 0. Else if last one greater than math.pi times 5 divided by 4 and direction is less than or equal to math.pi times 7 divided by 4, and actually we'll share, so they all get 1 equal and 1 not. And current animation not equal animations dot walking right. This dot current animation equals animations dot walking right. This dot current step equals 0. And actually, why don't we real quick, let's do this. Let's come in here and we're going to add a change animation thing. Let's say sequence is our parameter. This dot current step equals 0. We'll make this function here, so instead of doing this each time, we'll just call that function. This dot change animation dot walking, what was this, right? This dot change animations dot walking left, or up. This dot change animations dot walking down left. And that shouldn't have been right, should it? Animations dot walking down. Okay, and let's test that out real quick. So, moving left, moving up, moving, or sorry, I was moving right before. Oh, okay, and that one's still facing right, which means I made a typo here. Maybe not. Down didn't quite work. So down less than or equal to, okay. So let's see what is down's direction. Okay. So down actually is negative. Interesting. Which actually I guess makes sense, yeah. because of how we're putting them in there. But we want to not, we want to make them not negative, or we want to make them negative. We want to not make it negative. So actually, to fix this, we'll do the next step that I was planning to do anyways. Let's make a helper function to do radian between .js, what we'll call it. Const radian between equals, so we'll pass in angle and then min and max angle. And this will just return basically what that if statement's doing, but it'll take into account the fact that the angle's actually a circle, so you can wrap around. So here we'll do, so we'll return if angle is greater than or equal to min and angle is less than or equal to max. So that's kind of that's the simple case there. But then we have the case where, so it may be wrapping around. So let's do math.py times 2 mod min. And then, math.py angle. No, what am I doing? Angle, yes. Math.py times 2 mod angle. Min, and then I think that should give us math.py times 2 mod. So if I have like say 3 pi, that should end up equaling 1 pi, or not, no, yes, no, yes, that's not 1 pi, word of operations, there we go, that's 2 pi, I'm doing this backwards, mod 2 times math.py, okay, so there we go, so that equals 1 pi, and then if I had, let's see, if I had negative pi, that should also equal 1 pi, but we'll end up with the negative on there, so 2 times pi, yeah, we should, I'm trying to think of a case, so like negative divided by 2, so this is the same as alright, my brain hurts. Let's just Google real quick. Cap radians between negative pi and pi. Wow, that found nothing. Clamp. It's the more proper term. Wrap angle. Oh, that's a function. How to wrap angle, blah, 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 how to wrap a float. Yeah, here we go. Blah, 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 modulo function, notate down a boundary case, blah, 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 blah. Yeah, see, they're doing a really complicated version, but you might actually have to. I was hoping there was a short version. Okay, it's a 2-line if you can look at the anyways. Wrap min max, wrap min. You could simply use wrap min max, doesn't cost of timing. Don't expect really that's it's not even Verify your input angle can reach, and you can also try. It's actually pretty clever. We could use that for now. Because this guy should work actually. So. And this might not be, performance-wise, this might not be the most optimal thing to use, but it's a clever idea. Oh, got a typo though. Gotta do math.py, or math dot for each of these, because that's how Java with script works. Math.py times 2. That's technically, that is 0. That's technically 1, 2, 3, 4, some number I didn't actually count, but too many, but 2, 4. So that's really like that, which is effectively 0 for all intents and purposes. That's just a rounding error because of floating point precision. But that's adequate. So that's that. Okay, and then negative pi. Still lets the number go negative, though. That's annoying. Well, I guess so. Like, because like negative math.pi divide by. Oh wait, though actually, that's what I wanted though, because I want it to go between negative pi and pi. So if we do negative math.pi, or let's see, let's do negative 3 pi, for example, 3 pi. That's the same as 1 pi. Okay, cool. That actually works as a nice little one-liner. Again, because trig functions aren't super duper ultra performant if you're like worrying about super high ultra performance, but we're not for now. So I like that. So actually I'm gonna call this clamp radian instead of radian between, well, or no, sorry, this is for a different thing. Clamp radian, we'll just put in here. Math.atan to, let's sine first, right? Yeah. Math.sine value, math.cosine value. Okay, so now we have that negative pi to pi bit. I'm glad the math for that was a little more complicated and that I wasn't just crazy. Okay, cool. So now then, so now for this guy, so like for, let's do a new screen real quick. New. Fill it white. Where are you, bucket? There you are. Bucket. New, or not new. Delete that one. Duplicate that one. Okay. So now that we've standardized our angle, we're always dealing with this is positive, this is negative, and at this point we end up with pi, and it may be negative or positive. So if we want an angle between 2 points, what we'll do is, yeah, actually we are going to implement a clamp function, because we'll just clamp the min and max, and then we can just, well, let's see. So if we have between, so this is our weirdest case since we're crossing the 0 boundary, which makes things weird. So this is math divided by 4, and this will end up being negative 4. Actually, that works just fine, because then we can just say between negative 4 and 4, and then this one we can say between 4. So this is actually our weird case back here, because this is where it's going to flip on us. So we're going to be, what, 3/4 over here, and then we're going to be negative 3/4 over here. So, let's see, one way we might be able to do this that's kind of simple is if we try two different things, and if either of them work, we're good. So if we do, and we will still, we'll still mod our angle, although I have these backwards. Math.pi mod 2, just in case we pass in like 8 times pi or something. Alright, so, and we're gonna min all of these. Pi mod 2. And angle. Actually, let's do this. Divided by math.pi divided by 2. And actually, instead of calling that angle, let's call that rad. So we know to pass in radian. Mod min equals min divided by math.pi 2, and mod max equals max divided by math.pi mod 2. Okay. And then what we'll do, we'll return if angle is greater than or equal to mod min, and angle is less than or equal to mod max. So that'll handle the case of like this guy over here. And then what we can do, so while here this creates a weird cutoff because we are 3/4 or negative 3/4. If we were to say add 2 pi to it, then we go back to not being, well, no, we are still weird there. Well, we have to add 2 pi and then mod 2 pi again. Which might be redundant, but should work. But if we add pi 2 and then we mod pi 2, we get to back to 3 pi or 4 pi, so that works on this half of the angle. Again, maybe not exactly the most efficient, but it'll be simple. So it'll be simpler. So mod rad plus math dot pi times 2 mod dot pi times 2 is greater than or equal to, and here we'll just make a little helper function for this. Oh, and that's supposed to be mod pi. Const mod pi 2 equals rad. And this little helper we won't export, it's just a helper just for this function. Rad mod math.pi times 2. So then this is mod pi 2 rad, mod pi 2 min, mod pi 2 max. Oh, and actually because it's declared as a const, it has to go up here. Well, no, it doesn't, but we'll put it up there. Okay, so that, and then this guy is going to be mod rad plus math.pi times 2 greater than or equal to mod rad mod min plus math.pi 2 and mod rad plus math.pi times 2 is less than or equal to mod rad mod max plus math.pi 2. And actually, since we're modding these, here we don't actually have to mod them a second time because modding will take it back down. So actually we can just do mod rad rad min, mod rad, mod rad min. Then we don't have to have those extras there. Oh, sorry, mod pi 2 for these. Okay, and then if either of those, if either of those ends up being true, then we know we're good, because really we're checking the same, from a like trig angle perspective, we're checking the same thing both times here, but from a like normal number line that doesn't wrap and connect to itself, one of these will be true in theory, if I did it right. There's a high chance I did it wrong, but let's try. Radian between direction, and then so math.pi divide by 2, and we should also, with how we've done that, we should be able to do negative or positive radians, whichever one is easiest to read for us. Okay, so that one's that, and let's just check that one first. We'll check one at a time. Okay, so moving left. Nope, doesn't work. Okay, so what is that show there? All right, so no bueno. So let's go here. Turn, and we'll console log each of these bits in here and see what we're getting so we can compare them. So, plop. So we'll do the two booleans first. Oops. Hang on one sec. Sorry, gotta sneeze. Sorry about that. I don't want to sneeze in everyone's ear. Okay, so we'll do the 2-bit. So really, both of those should be false. And then let's go. We'll take this guy. We'll break it out into component bits so we can just look at them. So blah blah. We don't need that again, and that one. And then these guys. And we're just going to look at each number and make sure it makes sense. Don't need that one again. Okay. And then real quick, to make it easier to figure out where our cutoff is, we'll put just output a line there, pipe. Okay, so we have, alright, so that's fourth. Okay, so here's where our issue is here. So that negative fourth got turned into a positive fourth on us. So we have some kind of issue with our math here. And then this guy is, so that one's right. That one's also right, I think. Let's see. 3.14 times 7 divided by 5. No, it's not. What is that one? 5.49 minus 3.14. 3/4. It's about 3/4 pi. 3, 4, 7. Oh, because I divided by 5 earlier. It is. Right. Times 7 divided by 4. There we go. If I multiply right, it works out. Okay. So yeah, so that is 7/4. So this one is good. This should have stayed negative, but instead it turned positive. So let's take a look at that. So this, oh wait, do I, oh, well, that makes a difference. Alright, let's see if that works now. Alright, still not work. Wait, do I have a compiler error now? No, Yes, maybe? No, that's old. No. Okay, so, oh wait, I didn't change this guy. Okay. Alright. So now those numbers are right, but then why? So our angle is 0. So our angle should be less than or equal to that. Oh, there's another problem. Less than, no. Oh, wait, no. This bit is right. I passed this part in wrong. There we go. Now we can face left. Okay. And then next up, radian between. So direction, and then our minimum is math.pi divided by 4. And our maximum is math.pi times 3 divided by 4. Okay. So let's see if he can still go up. He can still go up. Good. Now, radian between direction. So between that is our minimum. And that's our maximum. Okay, that's right. And see, I could use this here, or I can do, what is this, negative 3/4 pi at this point for the max, but that's confusing if you look at min and max, but the max is somehow way smaller than the min. So that's why I'm choosing to use these. That way it's always, in a normal like number line sense, we're always growing between each one of these. And I'll just make it a lot easier to understand when we come back and look at it, 4 weeks from now when we haven't been looking at it constantly. We don't necessarily remember all the little decisions that went into everything. Okay. So now we should have all 4 directions. Bum, 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 bum. Perfect. He does kind of flicker if I change him fast enough, but as that really that happens in like normal games anyways. Not really a way around that. Okay. Cool. It's kind of moving. Oh, okay. So here's that issue I was avoiding earlier, that with the whole 2 things touching at the same point, because now with our function, it doesn't have that sometimes greater than or equal to, and just other times just greater than or equal to. So let's actually change this function, the radian function, to always expect it to be like this. That way, so it's inclusive of the min, but exclusive of our max, is how we phrase that in code. Or, well, in math in general, I guess. And now we shouldn't get that flicker, and it'll pick one based on which way I go. So there we go. Now we're good. Now we aren't having a spasm if we try to go 2 directions at once. So cool. Moving around a little bit. Nice. Alright, cool. So there's our moving around. So now why don't we go ahead, since we have this nice attack animations, let's go ahead and we'll sequence those up too. So we have, alright, so this was our last number we used, so we're running up. So our attack animation starts there and goes for 5. So player. So, was it attack right? Yeah, attack right is first. So 40 to 45. Attack after that is left. Is 46 through 51. Oop. Attack. Man. Attack. Down is next. 57. Attack up is probably next after that. We'll double check. 63. Attack up. Yep. Cool. Okay. And then, so let's make it, let's go make it so he can attack then. So we'll go game scene. And now, after player move, we're going to do player attack since last, and then player attack. So here we're going, so first up, we don't want to like be able to infinity attack, like he shouldn't swing his sword every single time I hit space if I like suddenly start spamming space. We want him to be able to attack with some frequency, and that frequency is probably, how long does it take to do one swing, and then maybe a little bit of a delay. So we'll call that attack speed. So attack speed. And we'll do, just like we'll do that number of seconds. So let's just do a little thinking for a second. So if we have our state change speed as 0.2, and we have 5 frames per attack, so that should mean it takes 1 second to complete the attack. And then he probably can't swing the split second he finishes his move, so let's say add an extra 0.2 seconds on top of that. So let's say our attack speed is 1.2 seconds. So after he swings, he has to wait 1.2 seconds to be able to swing again. Okay. And then we'll go in here and let's add a function called attack. Now receive since last. Oh, and let's add a last attacked as well. So this will be the time when he last attacked, which means we want to use now. And we'll go back to game scene. So we'll call this .player.attack since last and now. And actually we don't need since last for this one, so we'll just do now. And we'll make sure to pass now in here. Okay. And then and we'll do if blah blah blah, because like the player's going to control whether he's showing his attack, but we're going to have to do something here, hit something to actually make the attack work. But for now we'll get him to swing his sword first, so we'll do now. And then if this dot last attacked plus this dot attack speed times 1000, because we need to convert to milliseconds, is less than or equal to now. And actually let's put now on the right side. I tend to like to use greater than more often than less than, unless I'm doing both, just because it tends to make things easier to think about. So basically if now is more than the time he last attacked plus his delay, his wait time, then we can go ahead and attack again. So we'll do last attacked equals now, and then we're going to change his current animation to, and let's destructure the ones we can. Attack speed and animations. Animations dot attack, and so here we have to check which direction he has. And I guess if we start an attack and then we start moving up, we want to probably finish the attack facing that direction before we change our direction for moving, because like we wouldn't want to like change direction mid-attack, because then you could do like a 360 attack and that would probably be kind of OP. But let's also, and we'll add a attacking boolean here. So, because we're going to need this guy, because if we're attacking, we don't want to change our direction. So we're going to check, we're only going to check to change the walking direction if we're not attacking. If we're attacking, we're going to keep attacking. And then we also need, so we'll set this to attacking true. And then we're also going to need to stop attacking so we can switch back to our moving direction. So if let's see, if this dot attacking and now is greater than or equal to this dot attacking, or sorry, this dot, how do we want to do this? We could say attack speed, but then there's going to be like an awkward 0.2 seconds where we should have switched back, but we didn't. So actually, let's do controls the changing step? That's in move, right? Yeah. So let's do. We'll check if we've finished. Instead of using time, we'll check if we've finished um, moving, completing one animation loop. So if current step equals current animation dot length, so how many steps are in there, and we need to destructure current step. Okay, so basically, if we finish the attack animation, we're going to stop attacking. Attacking equals false. And then that'll allow us to set his direction. Okay, so last attack, attacking, and then here we need to do, we need to pick which attack direction we're going to do based on the direction. So I'm just going to copy paste this guy for now. And we may tweak this later so it's not quite as verbose, but for now this will be fine. So, if we're in the right way, we're going to attack right, or we're going to attack up, or we're going to attack left, or we're going to attack down. And I just realized that we didn't actually, back here, we want to check if we're hitting the button to attack. So we're going to extract out input manager from our engine, and it actually lives in scene manager inside engine. So if, and we'll use spacebar as our attack key for now. So if input manager is key down, keys.space, so if we're holding the space key down, then we're gonna attack. Well, we'll check if we can attack, and if we can, our player's going to start the attack animation, and then we have to do code in here. And we'll just add a console log here. Attacking. And, oh, we need to make sure this guy returns true or false. Okay. And get rid of this there. Okay. So let's see what havoc that causes. Oh, and let's get rid of that console log. So rad between and player are both spitting console. I got that one already. Rad between. Actually switch this guy back to that. Okay. So. Whoop, refreshed my stream creator. Okay. Or my, what's it called? Creator dashboard stream manager. Okay. So. Hold space. Hey, look at that. He attacks and then keeps attacking forever. Okay. So. We start attacking right, so that's good. But then we don't stop. Oh, and I can't actually... Oh, you know what? I think I'm one frame off on his attack animation too. Yeah. See how he flicks to the other side? I think I added one too many numbers to this guy here. So attack right. Yeah, I did. And then this should be 45 to 49. And then this should be 50 to 54. And then this should be 55 to 59. Because it's 5 frames, but that includes 55. So 55, 6, 7, 8, 9. That's 5. Okay, so now swing. Okay, so his animation part looks right. He's not switching back, though. So it looks like we got the animation good. So let's go back to player. And let's see what... So this bit isn't working quite right. So let's do this. Console.log, current step, current animation dot length. So let's see. It should check once for each. Oh, right. So our length is always 5, but our current step is always going to be between 0 and 4. We never quite make it to 5. So -1. Okay. So now swing, stops attacking. Perfect. And then, so I'll go, let's see if I can do this. So he's going right. I'm going to swing and then move up. So swing, moving up. Okay, cool. Looks a little awkward, and that we might choose later, maybe the player can't walk while he's attacking because it doesn't actually show him walking while he's attacking, so why can't he? But for now, we'll stick with this. Okay. And now he's got a case of he's always jogging in place. So let's implement the idle animation. So that's what these first ones were. So each of these are 4 sprites, or 4 frames, so let's go implement them. So idle down was first. Yep. Idle down, and that's 0 to 3, because 0, 1, 2, 3, 4, or 0, 1, 2, 3, that's 4 total. Hang on, sorry. Okay. And then idle, what's next? Next we have idle right. Idle right, so that would be 4 to 7. Idle down, up. Oh wait, no. Idle left, and then idle up. Range 8 to 11, and idle up is range 12 to 15. Cool. Okay, so now what we're going to do is let's go back to our player here. And so here we have these directions, and we're always setting him to walking. So the direction bits are still good. Now it's just a matter of, is his velocity 0 or not? If it's 0, we're going to use idle. If it's not 0, we're going to use walking. So if if velocity, and velocity is how fast we're moving in the direction we're facing. If velocity equals 0, and actually we can even, so here, we'll do it this way first, and then I'll show you the kind of how we can crunch it up to make it less codey. Else that idle right. So, but we can actually do, since a lot of this is the same, we can just come in here and we can be like, if velocity equals 0, do that, else do that. And then we don't need this extra if statement. Okay. And ditto for this guy. Animations.idle up. Ditto for this guy. Velocity. And actually, we can even go a little cleaner than this. If velocity, so that in JavaScript, if you check a number and you want it to be a Boolean, basically anything that isn't 0 is true. So basically, if he's moving at all, even negative or positive, doesn't matter, he'll walk. Otherwise, he'll idle. And then you just switch these around. Idle up. Oh, why did I blink all that out? Idle left. Idle down. Okay, and then we need to update this bit here because we don't want it to constantly reset because we're not walking, so we need to include both of those. So whenever I have to check a value for more than one thing, I usually like to go use this guy. Idle right dot contain. Is it contain? Yeah, contains. Contain is that. So if either one of, if what this thing is doing is in this array, then this will be true. Oh, except not. If he's not doing one of those. Okay, I'm going to copy this guy. This, and then we'll just swap out these up, left, down, down. Okay. Whoops. Oh, it includes different languages. It's different function names. Thought that looked funny. Okay, there we go. Alright, so now, there we go. So he's idling. If I start walking left, he still idles. He's lazy now. So where do we goof? Okay. Oh, okay, so that's a little tricky here now, because it'll only go into here now if one of these is, if it's not either of these, but if it's one of these, it won't go in here. So that's why he has a case of lazies. Oh, okay. I know what we can do. Let's remove this check at all, or completely. And then let's, so we'll yank that check out completely. And then we're going to go into our change animation thing here. And if we're already doing this one, we just won't change anything. So if this dot current animation not equals sequence, then we'll just return. We won't change anything. So that way we can now just call change animation every time and pass in what we want to be doing. And if we're already doing that, we won't change. Now he's too hyper again. Alright, can't you just chill? Alright, let's see. So, alright, so our velocity. Alright, so we're specifically looking at this one. So let's console log our velocity. And I'm wondering if we don't maybe have a rounding error here, like we've seen pop up a couple other places, where it's like, yep, there we go. So what we have there is, let me hold down 0 for like half an hour. Oh, technically it's, yeah, 5. There. So that's the amount we're moving. When you round that out and put it in pixel land, that would take us half a century to move 1 pixel. So we're basically moving 0. But the problem is, for the purposes of, is it a Boolean or not? Yes, technically it still is, because it's not 0, and only pure 0 ends up equaling false. So what we'll do is we'll just trim it up a little bit. And you have to do this a lot when you have values that can be when you have floating point values, because they end up with these rounding errors a lot. And it's like, you know, most of the time they don't really matter. The only time a number like that would matter would be like if you're trying to like calculate, you know, I don't know, electron interactions or something in a hardcore physics simulator, like you might use in a laboratory. But for us, it doesn't. So all we're gonna do here, I'm just gonna chop. Well, yeah, that'll work, because our velocity is always really is bigger numbers. So even 1 is moving 1 pixel a second. So we'll chop off that little fraction of a second. All right. So not moving. Hit right or hit right. Yep. Yeah. He moves. I let go. He stops. Let go. Stop. Go. Stop. Go. Stop. Go. All right. Cool. So now we have 3 different animations for our player. He can run in 4 directions, and he can swing his sword. Yay! He's alive. Cool. So I think that's pretty good for our player right now. So let's get rid of that console log. Okay, so now let's go ahead and... So we could either do the map now and start populating the map, or we could go ahead and get some monsters in there. Eeny, meeny, miny, mo. Let's go ahead. We'll populate the map so we can do his collision. So let's actually. Actually, no. Let's do the monsters. That's. so let's go ahead. We'll create a new file. We'll do bat. Do we want to do bat or chicken first? Let's do chicken. Still have nightmares of the chickens in pretty much every Zelda game ever. Most dangerous hardcore enemy. Okay, so chicken. I'm going to copy it over to this assets folder. Let's open up chicken in Photoshop. Okay, so our chicken doesn't actually have an attack animation. He just has 4 walking animations here. And if we wanted to idle, we could make this one be a quote-unquote animation, a 1-frame animation. But we'll just say that our monsters are always moving. I don't guess there's a reason to make our chicken idle if he's trying to kill us. So, make a game sprite with those 4 animations. So, chicken, export default const, chicken extends sheet sprite. Okay. And export default class. There we go. Okay. So, and I don't remember what we have here. So let's copy pasta. This guy. So that's chicken. Trim down our animations. Okay, so first is up. So he's up, right, down, left. So clockwise. So that's a nice arrangement. Makes it easy to remember. So walking up, right, down, left. Okay, and then it's 3 frames each, right? Yeah. So 0 to 2, 3 to 5, 6 to 8, and 9 to 11. Okay. And then we'll have him walking right. Okay. So it's sprite size. Let's figure that out real quick. So just like with the other, we'll do a little math. So it is 96 wide. So divide by 3 is 32. And then 128 divided by 3, or divided by 4, it's also 32. Oh, excuse me. So this one's a nice even 32, 32. He's pretty tiny as well, so we're gonna crank up his size like we did the chicken, or like we did our player as well. So 32 times, he may need to even be more than that, because he's big. Well, that might be right. We'll try that. Okay, and then, okay, so let's go create a chicken real quick. So, go game scene. So normally we'll like spawn chickens like we did in the zombie game. But for now we'll just make 1 chicken just so we can test them, and we'll set them near our player. Chicken. And we'll do const chicken equals chicken.create. And oh, I'm still scaling the player. Okay. I thought that was weird that I had to... Oh. Don't want to do the chicken just yet. I'm pausing chicken. Let's not load chicken for a second. Don't load chicken, don't create chicken. Yeah, okay. Yeah, I thought that number was too big, but... Okay, back to normal. Okay, so game scene, which means chicken is also probably too big. Let's do it anyway, super chicken. Okay, and then chicken.x equals, and we'll just kind of throw it on there somewhere. Chicken.y equals 500, and then root sprite.addChild chicken. Okay, so, whoop, he blew up. Okay, can I read property image.width? Why didn't we load our image? Did I typo? No, that should be right. Intro real. call load, right? Did I put load back? Yeah. Create. Did I goof? I'm using create. I'm calling load. There it is. IntelliJ still has something against me importing my sprites. Chicken. Not so many dots. Okay. There we go. Super ultra mega chicken. Cool. And then, just like player, we'll call this enemies move, even though we'll just move chicken for now. And just temporarily we'll add chicken up here, so we can save chicken for later. Chicken. And then we'll do enemies move since last now. And then this dot chicken dot move since last and now. And chicken's animating now. Does chicken have no feet? Or did I chop them off? Oh yeah, he doesn't really have any feet from this direction, huh? Alright, super mega chicken. So, and right now I can walk through them and stuff, and I'm always behind. So that kind of gives the illusion that it's floating because I get our z and x wrong. So what we'll actually end up doing is, so standing here on this side of the chicken, I should be behind him. And then here I wouldn't actually be able to walk because I'm inside the chicken. But then when my feet get here, so my feet are actually below the my feet are below the chicken's feet. We should actually switch the z-index of two things. And let's go to this guy real quick. And I want to... Hello. Yeah. Yep. Yeah. That would be like boss chicken. Yeah. Oh man. In video games, chickens freak me out already because in, most Zelda games, if you go hit a chicken too much, it summons the chicken swarm of doom, which you cannot defeat no matter what you do. You can either die or run. Okay. So let's add a swap function here. And I was going to call it A and B because they're both children. And then what we're going to do is we're just going to have these switch places, basically. Actually, no. Let's think. Do we want to do... Yeah, we'll do that for now. We may change when we get down and we have more than two going on. We may change how we deal with this, but for now we'll go with that. So basically we're just going to do this dot children equals, and we need the indexes of both. So index A equals this dot children dot index of A. Const index B equals this dot children dot index of B. So we get each of their places. And then, so to swap these in a functional way, so I could do this real quick. Children index A equals B, and this dot children index B equals A. So that would work, but that's not what we call functional programming. So basically, yeah. But this isn't functional right here because I'm changing children, and I don't want to change the array of children. I want to switch, or I want to create a new array and assign that new array to children. So we're not going to do that. So what we're going to do is and let's see, I've not actually done this, so let's figure it out together. So we need to take everything before both children. So we're going to take the minimum between the two of them, index A, index B. So here, let's actually draw this out so we can think about it. New, hide that one. Okay. So we have some array of things. So we'll just use numbers 1, 2, 3, 4, 5. And say we want to swap these two. So we want it to end up being 1, 4, 2, or 3, 2, 5. So we get the index, so we'll call that A, that B. Why not hide the search in taskbar? It takes up too much space. Hide the search in taskbar. Which search do you mean? Oh, this guy? Because I don't even notice it anymore. That's actually not a bad idea. I literally have never used Cortana's stuff before. Taskbar settings. Lock. Not actually sure where you go to hide it. Right click, search. Right click. Hidden. Nice, thank you. Yeah, my brain just kind of filters out annoying things and I stop noticing them after a while. Alright, cool. So we're going to swap these guys. So we'll call this one A, this one B. So we have index A, which is 1, because we always start from 0, so 0, 1. And then index B is 3, 0, 1, 2, 3. So, to build up our new array, we're going to start by taking everything from 0 to the minimum between our two indexes. So in this case, that would be 0 and 1. So really, that's just this part. So that would give us 1. Then we want to insert the one child that's smallest. So we'll just do, and this is just kind of pseudo-codey, so whichever one of these wins, use that child. Oh, actually, it doesn't even have to be pseudocode because we can just, we can do children min IA IB. So that'll give us our example here, or actually, well, we want to put, we'll do max here actually, because we want to, whichever one was last, we want now first. So this would give us the 4, because 3 is our max, so this would give us 4. Then our next step here, we have to either put the next children, because like if they were, say, together, so say in a different example, we were swapping these two, we would want to put the next child. But if they have a gap, as in this example, we want to instead slice to the next index. So we'd have to do something like let's see, slice from the minimum of these two plus 1, and then we go to let's think about this. Okay, let's just go write some code for this. I think it'll actually be easier in this case. So we'll start out with what we have, which we did, and then we'll do the child, the max child, because that'll be the last one that we're switching. and then we'll fill in the rest in a bit, but the end part is going to be the max child plus 1 and everything else. So that bit would give us the 5. And so then really it's just this middle part that gets a little funny. So if we take, let's just write this out real quick. This may or may not be what we're going to use here. So if we take the minimum of these plus, and then we go to the max between the two, assuming we had the gap, that would work. And then this would be the min here. So assuming it has a gap here, this works. And let's actually, we can go play with it here. So const, type, const array 1, 2, 3, 4, 5. And then we'll do index A equals 1, const index B equals 3. So we can do array.slice 0 to math.min, index A, index B. And then we can do array math.max, index A, index B. Oops, didn't need to hit enter. And then we can do array.slice math.min, index A, index B, plus 1, math.max, index A, index B, and then math.min, index A, index B, and then array.slice math.max, index A, index B, plus 1. So that works if they're connected, but then, and let's actually refresh real quick. Gonna do the indexes as lets, that way I can change them. Okay, so say instead I want to swap 2, so I want to swap 3 and 2. Whoop. This, actually that did work out. So let's think about that. Why did that work? So if we have, oh, actually, yeah, that makes a lot of sense. So what ends up happening is this guy ends up not having anything because they're right next to one another. So this essentially slices 0 records. So it doesn't do anything when they're right next to one another. And then this guy caught all the ending stuff after it. So actually, that may work, and we might not have to do anything special. So let's say, let's test, say we're on 3 and 4. Whoops. No lead on that second time I use it. So 3 and 4. So these would be the 4 and 5 in our array. Let's see if that works. So 1, 2, 3, 4, 5, 4. Cool. Let's go with 1 and 2. And actually, added bonus, we'll make these backwards just to double check that we don't have a goof there. Cool. All right, so that works. That was actually easier than I thought it was going to be. And let's see. So dot there, dot there. All right, cool. So, and actually instead of switch, let's call it swap. Okay. So now going back where we were a second ago. So we want now if the player's feet get below the chicken's feet, or well, just below the sprite. So the chicken ends right here, we end right here. We want to swap the two around to make sure that the player is after, and if I go above, I want to swap it back. So let's go here. We'll add a new function for that. So after we move the player, let the player attack, move the enemies, we'll add another. We'll call arrange children, or we'll just call range. And this one's job is just going to be to flip through each thing we're showing and make sure everything's in the right order. So we have bu- 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 yeah, sorry, just checking something. Okay. Um, okay, so let's say, so we'll do it this way. Let's create an array of all the things to arrange, and then we'll sort these. We'll run just the normal sort function. And actually, I don't remember if JavaScript sort function returns. It mutates, okay. So we'll do const to sort to arrange equals that. And then, so this will just go through and sort based on whatever. So for our sort function here, if it's negative number, that means A goes before B. If it's positive number, that means B goes before A. And if it's 0, that means they're equal. So it won't swap either of them. So in this case, so what we can do when we're comparing numbers, which will be in this case, so we're going to be comparing a.x plus a.height, or sorry, a.y plus a.height, and b.y, b.height, because that'll give us the bottom of their feet. Or actually, not quite. We have to also take into account origin, which we've adjusted. So let's actually real quick go back to rectangle. Rectangle? Yeah, rectangle. It has an origin. So let's create a thing called bounds here, which will be calculated off of the origin. So it'll do that math for us, and it's going to give us a top left, bottom right instead of a x, y, and all that. So let's see. Top is going to be this dot x minus this dot origin because of how we use it. Oop, except y. Y. And then bottom will be this dot y minus this dot origin dot y plus this dot height. And then left is this dot x minus this dot origin dot x. And right is this dot x minus this dot origin dot x plus this dot height, or width. Is that right? Let me think. So if the origin is 50%, so here, let me draw it out so I can share with you guys. So I have my sprite here. Say the origin is here. So we'll say that we're 100 wide, 100 tall. My origin then, in this example, is 50-50. So if my x is, say, 10, well, if x is 10, that means this point here is 10-10 relative to the world, but it's really 50-50 relative to the sprite. But so that means taking my x into consideration, really my left edge then would be 10 minus 50, so negative 40 is my left edge. And then my right edge is 100 plus that. So yeah, so negative origin is right. Okay, so that gives us top, bottom, left, right, and that will make, that way we don't have to do that math everywhere, and make sure we remember to do that math everywhere. What am I looking for? Game scene. There it is. Okay, so then it's just a.bounds.bottom minus b.bounds.bottom. And we can do minus because, so say the bottom of this guy's 100, the bottom of this guy's 200. In that case, that would mean b comes first. So actually, we need to flip these around because of how we're doing them. So if b was 200 and a is 100, then b is lower, so I would want b to come first, and 200 minus 100 is greater than 0, so b would come first. If a was 200 and b was 100, this would be negative 100, so negative number means a goes first, so that should be good then. So now we'll just, we're not going to do the swap yet, but we'll just call arrange. So chicken comes first, which is right because it's lower. And then as I go, we should see that. There we go. Cool. So it swapped player and chicken. Okay, so now let's actually go here, and this is where I was kind of contemplating that whole swap thing. We actually, even though we made this, I don't think we're going to use it for this guy. I think we're going to create a new function called what are we going to call this? Order children. And really, all this is doing is that. So it'll just order them. And we'll want, at some point, we would want make sure all children are actually children. But for now, we won't worry about that bit. So then we can just do this.rootSprite.order children. Oh, I named it wrong. Order children. Okay. And where was I getting seen? Okay. And now work. So actually, yeah, and there's already one problem with this. My background's going to disappear because I'm setting that whole array, and my background isn't one of those. So it's just getting removed, basically. So that won't quite work either. So let's go make that function a little more complicated. So basically we'll go there's a couple ways we could do this. One would be to kind of implement a partial bubble sort, but that's a little more complicated than what I want to do right now. So why don't we just... you know what? Let's fix it over on this end. We'll just include map on the toArrange bit. So our map should always come first. So we'll just do this dot map, which we have to go back up and add that, and dot dot dot. Oh wait, actually I do have map in there already. Cool. Alright. So yeah, I think that ends up being easier. Okay, so now let's walk through my chicken. Whoop. Didn't quite work out how we wanted. Range. Okay, so chicken comes first. Wait, what? Player, chicken. Oh, no, sorry, I did do that backwards. Chicken actually comes last because we start back to front. So, yeah. I was right the first time when I had A back here. And in a lot of things, what we call this is, well, one of the things we call a Z index. There we go. So now I'm behind chicken, behind chicken, behind chicken. And so in the real game, we will collide with the chicken, so we won't actually be able to walk through the chicken. But if I get here, so it's a little off there because we shouldn't have popped in front until here. So let's actually let's go real quick. So part of my sprite thing is they have a background, and if it's set, they'll draw the background. So let's draw the background so we can actually tell what our bounds actually look like. Oh, right, because dang it, those guys don't support that anymore. I need to change that actually. Yeah, let's do. You don't have a render. Okay, let's go here and let's add this guy. Super dot render or super dot prototype render self dot call this ctx. Is that gonna work? If I go to background, give them back the background. No, it blows everything up. Hang on. Image sprite, render self isn't private, and oh, image sprite. There it is. Or not image sprite, just regular sprite. There we go. Okay, so now we're showing our bounding box. Ah, okay, so that's what it is. Why we popped up ahead of him, because our sprite grid is a little bit bigger than his feet, because when he swings down, we need room for the sword swoosh. So what we'll do, we're gonna have to add something that's like what do we want to call it? Let's call it padding, maybe. And then when we do the calculation, we'll omit padding from the bounds, I think, is how we'll do it. That might have side effects, but that's fine for now. So let's go all the way back to Sprite. And we're going to do... yeah, that'll work. So we'll do padding, which is going to be top left, bottom right. And then, so Sprite extends rectangle. Rectangle is where we, what did I do? Rectangle is where we just implemented that bounds function. So what we're going to do for Sprite, we're going to override that bounds function. We're then going to call super.bounds, and that's going to get that base bounds function from rectangle, and then from each side we're going to subtract our padding. So bounds dot we'll mutate it, so, or we'll create a new one. So top is going to be bounds.top minus padding.top. Bottom is bounds.bottom minus padding.bottom. There. Destructure padding out. Okay, and then left is bounds.left minus padding.left. Right is bounds.right minus padding.right. Okay, and then don't know if we want to use that for the background or not. I think we won't. I think we'll keep background using the not padded version, but then for the player we'll use the padded version. So oh, and we have to go set the padding on player. So let's actually go here and let's look at the padding. So let's set up a grid real quick so we can see that. Edit, preferences, grid. Okay, so our grid is, what's his width and height? 6752. Oh, they don't let me do an irregular shaped grid. Boo. So let's let's do it this way then. What did I say? 57 by, I don't remember. Numbers are hard. 52. Let me move you. 52 there. Okay. And then let's go figure out where the bottom of his foot is. And it'll differ a bit, so we'll kind of get a fuzzy number. So maybe like that number, 45 maybe. That seems pretty good. So basically our bottom padding then is 57 minus 42, or 52, sorry, minus 45. Words are hard too. What did I say? 45, yeah. So 52 minus 45. So padding for bottom is 7. Top 0, bottom 7. Left, right. We should probably do left and right padding too. We'll do his hand maybe. So 46 minus 67 is 21. No. Yes. Seems big. Guess so. And then from this side, and this is subtracted from 0, so we'll say 23, so just 23 on left. And then top, we'll say, so we'll do like the back of his head from this angle, so 18 we'll say. And we can always play with these numbers later. Okay, so now, with those numbers in play, let's see what happens. See when he switches. So he shouldn't switch for a little bit. Okay. So he didn't switch for a bit, but we need... Do we need more padding? I think we need more padding. Wait. Did I totally goof up on the math? I did. It's 17. Not 7. No, it isn't. Yes, it is. 45. Yeah, no, 52. I did do the right math. Wait, does chicken need padding too, maybe? No. Yeah, it does seem like it's the wrong... yeah, so we're making our chicken, or sorry, we're making our player times 4, so we need to multiply all the paddings times 4 as well. And really what we should do, instead of timesing it by 4, let's just use our scale value. Sprite.scale equals 4. And then I think we have to multiply bounds by scale as well. Oh, nope, that worked. Kinda. Nope, no, we never... Oh, because I accidentally bumped it to 17. Down, 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 and right about there. Come on, you can do it. Don't switch. Why didn't you switch? Where do you switch? You switch right there. It's a bit higher. Yeah, we need to go multiply bounds by scale. And scale belongs to Sprite, so we'll do it here. Scale. So we take the result of that and we multiply it by scale. Okay. Alright, wait, this time, now he's in front right away. That's backwards. Chicken player. It's even not what our thing says. Chicken player first. So let's console log this and see what we get here. Alright, so we got top 372, bottom 628. So let's see, what should it be? So if our player is 67 high, but we're chopping off, or sorry, he's 52 high, we're chopping off 7, so it should be 45. Then it should be 45 times 4 for his scale. This is bottom. Plus x. So we need to actually output x and y here so we can tell what that is. I'm going to output this .constructor.name so we can tell if we're looking at the chicken or the player. Okay, so player is X. Ah, that's the problem, because we're also multiplying the X here, and that won't work. So we're going to have to actually recalculate the whole bounds thing here for a rectangle, but include the actually we should have destructured origin x, y, width, height, so we don't have this over and over. Okay, so we'll actually copy this because we have to multiply it at a point before we do this math here. So, because we have to multiply it we have to multiply this guy minus padding dot bottom times scale, and then this guy minus padding dot right times scale, and then this one we have to add padding dot top times scale because we're bringing it down, and this one we have to multiply padding dot left times scale. Okay, and we won't use super anymore, and we'll combine these two. Okay, so let's see what mess that caused. Okay, so far so good. Go down, down, down. Whoop, he popped up too soon again, though. Should have popped up much further down. So, let's see what his bottom ended up being. Get that console log. Well, actually, console log's useless now. We have to take this one. This dot constructor dot name, this dot x, or destructure x, y, and that guy. Okay, and then if we go down, okay, well, actually, before we even move, let's just look at our player. So the difference between these two numbers should really be 52 minus our padding, both of our paddings, top and left. So 52, 45, 35, 27 times 4. So 108. What are the difference between our top and our bottom should be? So what do we have here? Our difference here is actually what? See, 868. That is wrong. So why is that wrong? Let's go look at our calculation again. For Sprite. Okay. Actually, real quick, let's double check that our padding is actually set how we think it should be set. Okay, so player, yeah, so we're using the right padding. Okay. So make sure, yeah, so our width and our height is 67. Wait, why is our width and height 67? Our width and height should actually be... Yeah, because we're taking the biggest one. Although actually, why do we... Yeah, no, that's right. Because we want it to be this square, but it doesn't need to be squared. I think that's where our issue is, actually. I think that needs to be 52. Because our sprite doesn't need to be squared. Oh, there we go. He actually looks better. I think I was stretching him out before. Okay. So, he still crosses too soon, though. But now let's look at the difference between our top and our height, our bottom. Okay, so 108. Okay, so that's what I said the difference should be. So our difference there is right now. So as I move down, alright, so let's move to the point where we flip. Okay, so there's where we flipped. I'm gonna scroll up a bit so it stops jerking. So bottom 628. Okay, so it did switch at the right bottom. It's just our bottoms aren't quite calculated how we expect them to be calculated. And why is that? So if our player, so let's check our player first. So if our player Y is 478, it should be 478 plus top padding times scale. Does that make sense actually? Minus origin. So that means this point should be 478. Should subtract origin times scale. I think that might be it, because we want to go up. Basically, minus the origin part should get us back up here, and that would include scale. So we should do minus scale. Yeah, okay. So I think we can do plus negative origin. I think that should work, and then we'll flip these around just so it's a little more pleasant to read. Minus origin.y plus that minus that, and that should be fine there, I think. Plus okay, see what that does. So going down, going down, going down, and still cut over too soon. Okay, so let's look at our player's math again. So Y is about 460. So top should be top padding or it should be Y plus top padding times scale, basically, if we get the rest of our math right. And our top padding is 18, so times 4 is what, 36, 72. So Y plus 72 is what it should end up being. Or no, sorry, that's not right. It should be Y minus origin. Y base, in this guy's case, basically minus half of him. Wait a second, are we still setting an origin for this guy? We are. We're setting it to half, yeah. And actually, you know what? An easier way we can check this is if we move him to the edge of the map. The edge of the map is 0, so top should be 0 when we're standing right here. There. Okay. So we have top 18. Top 18. So we're actually... Okay, oh wait, no, that's padding, sorry. 72. Okay, so actually our top did calculate right. Because it should be top times... Yeah. And his left should be padding times 4 as well at this point. So that would be 46, 92. Pretty close. We're not quite at the edge, so that seems right. His bottom then So top is good. Let's check bottom. So bottom should be at this point, because we're effectively 0 for the rest of that, should basically be what should it be? It should be his height times scale, and then we should be subtracting from that bottom times scale. So it should be 52 times 4, that's 108, or 208, and then minus 28, so 180. Alright, so that's right too. Interesting. So we actually seem to be calculating the values how we think. I'm wondering if this is because chicken, we're still doing that cheating thing, and in fact I bet it is. So let's go fix chicken real quick, just like we fixed player. So instead of multiplying by 8 here, we're going to do what we should have done, sprite.scale times 8. Oh, equals 8 rather. So we shouldn't really like noticeably change look, but then will affect how we calculate its bottom. Okay, switch now. I mean, that looks good, but it's not actually quite where we put his bottom, so interesting. Oh well, that works for now. We may have to revisit that once we have more things going on and we're making final adjustments, but that's good for now. I'm gonna pluck out the background. Okay, so I think that's probably a good stopping point. So I'll get this code pushed up a little later. I need to excuse me. Need to make sure I have all the right attribution in there for the assets we're pulling in before I push it up. So that'll take me a little bit to go check out that stuff and make sure I got that right. Close that guy. And then yeah, then we should be all set. So we'll continue this project on Sunday, and then remember that tomorrow we'll start our first like super beginner course. So if you're a beginner, join in on that, and then yeah, if you enjoyed, subscribe or follow, I guess, and feel free to ping me on Discord or Twitter, wherever. Yeah, have a great night, everyone. Bye.